In this question, we have Haley and Serge. They belong to a running club in Vancouver, and part of their training involves a 200-meter sprint. So we have, I actually just have Haley's information here. This is her 200-meter times. She ran one run in Vancouver and one in Lake Louise. So what we want to do is we're asked to, at which location was Haley's run time better when compared to the rest of the group? And that's what we can use z-scores with. So when we look at the formula for z-score, we have this formula right here. But what does it really mean? Well, a z-score is a standardized value that indicates the number of standard deviations a data value is above or below the mean. So we take our data value, in this case it'll be her time that she ran, and we subtract the mean, the average for the group, and we divide that by the standard deviation. And we'll get a number usually between -3 and +3, because almost 100% of our data is within 3 standard deviations of the mean. So let's take a look at the Vancouver numbers. In Vancouver, she had a time of 24.95. That's her data value. The club average was 25.75. So she was faster. Less time means she was faster than the average. And the standard deviation was 0.62 seconds. So those are our numbers right here for the Vancouver 200-meter run. The formula is the data value subtract the average or mean divided by the standard deviation. So our numbers are 24.95 minus 25.75, and that of course will give us a negative value because you're subtracting a bigger number from a smaller number. And then we divide by 0.62. So when I did that, I had 24.95 minus 24.95, subtract 25.75, and that gave me negative 0.8. Then I divide that by 0.62 because that was the standard deviation, and I get 1.290322. So first of all, it's a negative number, negative 1.29. Now, to 2 decimal places is good normally for z-scores. Later we'll learn about z-score tables, and they are normally recorded to 2 decimal places. So negative 1.29, that's our z-score. We'll look at that after, and we'll compare it to the number from Lake Louise. So in Lake Louise, we had, again, she's running, and her time in Lake Louise was 24.77, and we subtract the average, which was 25.75. So again, her time is faster than the average. Less time means she was faster. And we divide that by 0.60 to give us our z-score. So again, when I do this one, I get 1.33, and it is negative 1.33. So what do these numbers mean? Well, we can always put them on our standard z-score table, or on our chart. And we'll do that now. Often we want a larger z-score. Bigger is better. But in this case, less time is better. So Haley has a time of, or a z-score of negative 1.33. The lower z-score means that she did better compared to the rest of the group. The z-score of negative 1.29 is a little bit further out. So the further left you are in this table means the lower your time was compared to everybody else. And that's a good thing when you are running. So the question was, where was she faster compared to the rest of the group? And the answer to that is Lake Louise. And we found that by using z-scores.